Okay, this is the second part of section 4.6 or 4.7. And we're going to talk about the quadratic formula, but in fact we're really going to focus on one piece of the quadratic formula, and that piece is called the discriminant. So let's get started with a little review. First of all, if you have a quadratic and it's in standard form, so ax squared plus bx plus c, and it has to be equal to 0, and you want to know how to solve that. One way you could do to solve this is perform the quadratic formula. So x is going to equal negative b plus or minus the square root of b squared minus 4ac all over 2a. So hopefully you're remembering that song as you're writing down the formula. And the part that we're going to work on today is just this value. That value right underneath the radical sign. That is called the discriminant. Okay, so as we said in the previous slide, the discriminant is b squared minus 4ac. And you're probably thinking, why call it the discriminant? Well, when you hear the word discriminate, you're probably thinking you got to make choices. You're choosing one over the other. That's exactly what this does, b squared minus 4ac. It is going to determine the type of solutions you're going to have from that quadratic. So, for instance, there's 3 different cases. The discriminant could be positive, so that means it's going to be greater than 0. And when you have a value underneath the radical sign that's greater than 0, you will end up with 2 real solutions. Meaning that your quadratic will cross the x-axis. Now, what happens when your discriminant is equal to 0? Well, in that case, so you're really looking at the square root of 0. Well, the square root of 0 is 0. So when you plus or minus 0, you're going to get the same result. So you would have one real solution. And if you have one real solution, then that means that your parabola is only going to cross the x-axis or touch the x-axis at one point. Now, it could be concave up or concave down. I'm just drawing general concave ups. Well, your third case, the discriminant could be negative. Now, we haven't really talked about what happens when you have a negative value underneath the radical sign. But in that case, you will have no real solutions. Meaning, no real x-intercepts. So your parabola could be concave up, and in that case it will be above your x-axis. Or it might be concave down, and it would be below. It's going to be one or the other. It's just not going to cross your x-axis. One other thing. Just because it has no real solutions, it will still have 2 imaginary solutions. So when those real solutions do not exist, those solutions then are imaginary. And we're going to talk more about what that is next section. Okay, so let's go ahead and practice. We're going to find the type and the number of solutions for each. And the first problem we're going to do is problem number 3 in your notes. You have x squared plus 36 equals 12x. So I'm not asked to solve this quadratic. I don't really need to know what x is. I want to know what the type of solutions would be if I were to find x. So we don't have to go through the process to find it. All we're going to do is pick out the discriminant from our quadratic formula. B squared minus 4ac. But before we can find the discriminant, we need to set this equal to 0. You have to have your quadratic function in standard form, which means I'm just going to subtract the 12x. Okay, so a is 1, b is negative 12, and c is 36. Alright, so I have negative 12 squared minus 4 times a times my c value. And we get, when we simplify this, 144 minus 144. So our discriminant is 0. Well, what that means is if I have a 0 underneath the radical in my quadratic formula, I'm going to have the plus or minus the square root of 0. It's going to end up to be only one real solution. There you go. So I don't need to know what x is in order to find the type of x that it's going to be. Let's try another one. Problem number 4 in your notes, we have x squared plus 40 equals 12x again. Alright, so step 1, you got to get it set equal to 0 so that it's in standard form. Okay, so I did that. I subtracted my 12x over. And now I need to go through and find what is A, what is B, and what is C. So A is 1, B is negative 12, and C is 40. So using the discriminant, I get negative 12 squared minus 4 times A times my C value. When you go and you simplify that, you end up with negative 16. So that means that if your discriminant is negative, you have a negative underneath the radical, which means then you don't have any real solutions. You will end up with 2 imaginary solutions. Okay, as you may notice, we have problem number 5 in your notes. Don't worry about that at this time. We'll talk about that when we come back to class.